Now, let's move to Thompson atomic models, postulates of atomic models, and then you can see the postulates there. The postulates is talking about the constant that constitutes what? Atomicity. I have nothing much to say here, but the little I can say is to tell you that atom structures is positively charged sphere into which negatively charged electrons are embedded. Negative charges, I told us oftentimes that negative charge bodies, what they do, their function is to dispense or to move away electrons. Okay, to move away. That is just their general function. To move away electrons. Why positively charged body does what? Attracts, brings in charged electron. Though in literal elements of chemistry, we are meant to understand by fundamentals uh, that elements, when giving out electron, retains a positive charge. Then when receiving back electron, retains a negative charge. Okay, so when an element gives out an electron, it is called it is described as what? A positive, as is electropositive. Then when an element receives the electron, it is called what? Electronegative. As simple as that. So, but there are limitations to this. Thomson atomic models does not clearly explain the stability of an atom. This is the problem we are having, and the stability of an atom, like you should always know, or like should be known. You should understand that that limitation, the stability rather, is because of due to the octet figure or the octet number derived or gotten in the shells of an electron. You can imagine when you are, I don't know if you normally ride tire when you were small. If you know when you were a kid, you normally first lesson we learn is how to drive the tire, the wheel of a tire perfectly. And if you can do that, that simply means you will definitely get a car when you grow. That is what we are told. And whenever you start riding tire, that's definitely at the end of the day you will get a car from the tire, or from the ball rest, or from the wheel, something like that. So you discover that when you place a weight, let's assume you place a weight on the tire, one particular side. Most times we put our slippers. That's what I normally do. Okay, I fix my slippers is there. When I put my slippers, and then I start riding it, someone will hold me at the back, okay, at my clothes, and then we'll be riding the tire along the road. Now you discover that the tire, because of the material you fix there, is much, this much of load compared to the other end. What will happen now when the tire rolls close to or rolls towards that very place you fixed a weight? Okay, there is a mass there. Once it rolls toward that very end, what happens? The speed increases. Okay, there is an increase in speed immediately, automatically. So once it rolls and it gets to that very place, that it is either it gallops one, or it increases in speed. That shows that what? The other end is not satisfied by the same weight. There is no equilibrium in the rotation of the wheel. Simple. So the same thing happens to when a shell isn't that complete. What makes a shell complete is when they are up to an octet number. Octet number means that when they are 8 in number. That is why hydrogen have to react with what? With chlorine, because chlorine has one ion and hydrogen has chlorine has seven elements or electrons in the atomos shell, while hydrogen has one electron in the atomos shell. So one electron of hydrogen meets up with 7 electrons of chlorine. What will happen? In the atmosphere of chlorine has 7 because it's under group 7. Okay, and the atmosphere of hydrogen has 1 because it is under group 1 and also under group 7. That one is a different ball game or discussion. So when it meets up together, what will happen? What do you think will happen? There will be a perfect octet figure created, because at the end of the day, hydrogen will have what? a fulfilled mission, while chlorine is totally okay. But definitely what hydrogen gives off is total electron to what? To chlorine. There is no sharing of electron because hydrogen needs only 1 electron. So coming to Mr. 7 electron, definitely it's not going to get satisfaction, or rather it will be oversaturated or oversatisfied with that. So it doesn't need that. Rather, it will cause more harm than good. So what it does is that it gives its electron, it gives out its electron. So That is just it. So what happens? That is, at the end of the day, you discover that the element becomes what? Unstable, all because of that very activity. So until the element has gotten to an amount, certain amount of an octet figure, which it describes as what? The octet figure is called the octet number of an electron shell, which noble gases or inert gases has it. Argon, helium, and neon, all of these elements has it complete. So they are called noble gases. They don't react. They don't need to go and mix up with any other thing. It fails to explain the scattered alpha particles by the T metal foci. So foils rather, where you can check that during when we start talking about nuclear chemistry. I think that will be well understood. However, Rutherford, this in atomic theory, states that on his postulates, Rutherford atomic theory is based on alpha rays and scattered experiments. He credited with the discovery of another subatomic particles called nucleus. Subatomic, and it is under one of the dispersed neutrons, electrons, and protons. Okay, it's under neutron. We discover nucleus. Okay, nucleus are just the invisible particles that are found. That is why most times they say that a cell can rebirth a cell. So even a cell under mitochondria itself has a cell. Okay, so a cell has a cell, a cell has a cell. So every single particles or single tissues in the human body has some cells. So are the tissues, so are the particles in what? In atoms. They also have atoms to themselves, which they are called what? Subatoms. However, the postulate of Rutherford atomic theory said that nucleus is at the center of an atom where most of the charges and masses is concentrated. Electrons revolve around the nucleus in a circular orbit. Definitely we know this. All these things we don't need to start setting it. It has been explained that you should know all these things very, very well. I've told you about the revolving of a tire. I use a tire as a sample. How you put some masses on the tire while rotating, it gets to a point and then the circulation becomes very fast. The speed increases, another kind of a thing. So the limitation, you can see the limitation, and so on and so forth. Bohr's concept is the one that now goes with what we call the energy level. The energy level is represented with n equals to 1, 2, 3 down to what? All positive integers. 1, 2, 3 to positive integers. So they are called the quantum numbers. The orbits are the same number. So when we want to assign them, we assign them based on KLMN. These are called their energy level. Okay? It was created by physicists in 1913. Please, all these dates is very important. Most times they can just talk you with the question and every other thing can occur. But they are, in every of the analysis, they always ensure that they put, in every of the postulates, they ensure that they put what? A limitation, so that you have some clarity on what they really did. Okay, finally, atoms and numbers. We normally represent atomic number with Z and atomic mass with what? Atomic mass with A. So we have 20 calcium. So the atomic mass there is 40, and atomic number is what? The atomic mass there is what? 20. And atomic mass there is 40. So you can see there, it's written over there. So these are the way to represent this, to make the calculation. And etc. Many more of them anyways. Move to isotopes. Isotopes are elements, or is the occurrence of atoms of elements having the same atomic number but different what? Mass number. So the vice versa of this statement. So one that has the same atomic this one has atomic number, the same atomic number but different what? Mass number. One that has the same mass number but different atomic number is called isomers. Okay, so difference between isotopes is just the reverse case. Isomers and isotopes. You can see the isotopes listed here. All right, so let's stop here for the meantime. Definitely, I believe the class has really been enjoyed, but we still have other concepts to treat about, to discuss about. We have electrons, we have arrangement of electrons, we have orbital atoms and electronic structures of an atom. We have quantum number, how to calculate quantum numbers. These are the formulas, but I will not be able to talk about this. Maybe subsequent classes will continue from here. So we stopped at isotopes today. Have a wonderful time. Good night to you all.